Next, we're going to look at a bottom-up version of Mergesort. While Mergesort is easy to understand as a recursive program, this bottom-up version that has no recursion is also quite simple to understand and to code up. The basic idea is to think of the array as being a little, at the beginning, a set of little sorted subarrays of size 1. And then what this method will do is go through and merge those little subarrays of size 1 together in pairs to get subarrays of size 2. Then the whole array consists of sorted subarrays of size 2. Then we make another pass through to get size 4 and then size 8 and so forth. So as you can see in this example, we start out by merging the first two subarrays of size 1 to make an array of size 2 EM that's sorted. And then do the same thing for the next two elements and the next two and so forth until eventually, instead of 16 individual elements, we have 8 sorted subarrays of size 2. Then in another pass through, we can take the EM and the GR and merge them together to make EGMR, and the ES and the OR, merge those together to make EORS and so forth, and we have 4 subarrays of size 4. One more pass makes 2 subarrays of size 8, and then the last pass is just a sorted array. The bottom line in this is a sequence of passes through the whole array, and there's no recursion needed at all. It's extremely easy to code up, as you can see from this code. We use the same merge code as before, and we take a nested for loop. The first one is the size of the subarray. And this loop gets executed only log n times because each time we double the size of the subarray until we get to n. And then we pass through picking out from low to low plus size minus 1, and then the next part is low plus size minus 1. Until we run to the end of the array, we might not have a full subarray of size SZ. That is a fully complete industrial strength code for sorting. The only downside, as with regular merge sort, is that it uses extra space proportional to the size of the array. But otherwise, that's a fine method for merging. That's bottom-up merge sort. If you look at this visual trace, you can see how it works. The thing is totally unsorted. Then it gets sorted into subarrays of size 4, then 8, 16, and 32. Now in this case, the second subarray to be sorted is smaller, but the merge routine doesn't really care about that so much. It can merge things that are not equal in size, and then we get a final sorted array. Whatever the size, bottom-up merge sort gets the job done in log n passes, each pass using about n compares for a total cost of about n log n.